Welcome back again to solving problems on engineering mechanics. Problem set 2.5, solution to 2.68. You are very likely to get such type of questions in your JEE main if you are preparing for IIT entrance examination. In fact, such a question came in IIT JEE main a few years back. Now, look at the statement. You may get in gate also. A ball of weight Q and radius R is attached by a string AD. AD is a string. This ball is attached with this string to a vertical wall. This is a vertical wall. The string is attached here with the vertical wall, and this point is attached to the ball. Determine the tensile forces in the string and the pressure RB. Here, the pressure RB against the wall at B. If Q is equal to 35.6 Newton, radius of the ball is 75 millimeter, and AB is given as 100 millimeter. There is no friction. Now look, what is given, the data given are Q is equal to 35.6 Newton R. The radius, that is from C to B or from C to D or from C to this point, is 75 mm. AB, the distance between this point and the point where the ball is touching the wall, is 100 millimeter. Now, what is to be understood is, when you extend this line, it will pass through C, right? It will pass through the point C. Let me join it. And let this angle is equal to alpha. Let angle ACB is equal to alpha. So, here, since this is a spherical surface, so there will be only one point of contact. And this line is the wall is the tangent, so this radius is the normal. So, here this angle is 90 degree. So, ABC is a right angle triangle. So, if you take tan of alpha, it will be AB over CB. AB over CB, put the value of AB, put the value of CB, millimeter cancels. So, alpha is equal to tan inverse of 100 over 75. Put it in a scientific calculator. This exactly comes out to be 53.13010 degree. And I hope you know how to convert a given degree, a measure of angle, to minutes of arc and seconds of arc using a scientific calculator. Alpha comes out to be 53 degrees, 7 minutes, 48.37 seconds of arc. Now, what is to be understood? Look, there are three forces. The tensile force in the string, if you consider the point D, it will be away from the point D. If you consider the point A, it will be away from the point A. The same force S in the string AD. And the Q, the weight of the ball vertically downward, because the earth is pulling it down due to its weight, mg. Then RB, the reaction force at point B. Here, this ball will apply some action force, so to this side will be a reaction force B. And from vector, you know, given there is a vector, supposing this is a vector, you can shift it parallelly, means you can shift it from here to here. As long as you don't change the magnitude, which is represented by the length of the arrow and the direction, so long as you don't change the direction and magnitude, you can shift it. So, that is the basic principle of vector analysis. Now, there are three forces, S, Q and RB. Now, the question is, the ball is in equilibrium. Equilibrium. Means, jaisa hai, aisa hai. The way it is remaining like that under the action of the forces S, Q and RB. Now, so I explained from the triangle ACB, which I have drawn it here. Tan alpha is found out by 100 by 75, so alpha has been already calculated. Now let us draw the free body diagram at point C. Means you can shift this reaction force RB parallel to itself and show it here. This will be your RB. This is your tension forces and this is your Q. So at point C there are three forces, RB, S and Q. So the free body diagram at point C looks like this. At point C, this is your point C, it looks like this. Now the course, right? So now look, there are three forces. So if you resolve S, this tension force in the string along y-axis by dropping a perpendicular means making this 90, this part from C to this point. This will be your S time, this will be your S times sine alpha, S times sine alpha, and that is being opposed by Q. So if their magnitudes are equal, they will cancel. So sigma y is equal to 0. So for sigma y is equal to 0, S sine alpha is Q. So sine alpha goes to the right hand side. Put the value as Q and value of alpha. This comes out to be 44.499 Newton. That is nearly 44.5 Newton. Now then let us apply sigma x is equal to 0. Now which are the forces along x-axis? This RB reaction force is already along negative x-axis, and the component of this force, tension force in the string along positive x-axis will be this much. Now how much will be this much? From here to here, if you take in this triangle cosine of alpha, that it will be base over hypotenuse, and cross multiply, you get this much length as equal to S cos alpha. So S cos alpha is being opposed by RB because they are opposite. So if their magnitudes are equal, they will cancel. So sigma x will be 0. So RB is equal to S cos alpha. Put the value of S we just calculated and put the value of alpha, take cosine and multiply, you get 26.7 Newton. Now what is to be understood here is for three non-parallel forces in a plane to be in equilibrium, they must have a common point of intersection, and the resultant of any two must be equal in magnitude and opposite to the direction of the third one for the condition of equilibrium. Means what do you mean by that? Means if you consider this and this, then their resultant will be this one. Now this one can be balanced if there is a force exactly opposite to that and equal in magnitude. Now similarly, if you consider these two, this S and this RB, and construct a parallelogram to find the resultant, the resultant of S and RB will be to this side, and this must be exactly opposite to Q and equal in magnitude to cancel the effect of Q. Similarly, if you consider S and Q as the two sides of an adjacent parallelogram and try to find out the resultant of S and Q by drawing a parallelogram like this, then this will be the resultant of Q and S, and that has to be exactly equal and opposite to RB. Then only that will be cancelled. Means, so they have to be concurrent. The three forces have to be concurrent. What I mean to say is, supposing you have a force like this and you have another force like this, both are concurrent here, their resultant will be, if you draw a parallelogram, will be to this side. Now can another force, let's say this one, can this force cancel the effect of the combined effect of these two forces, this force and this force? The combined effect of this and this is to this side, and this one is not exactly opposite to this. So in such a situation, the resultant of this and this will not be 0. So because these two have this point as the common point, and if you extend this one, this point is not same thing as this point, so it will not be in equilibrium. So for in equilibrium, there have to be a common point of concurrence, and the resultant of any two must be equal and opposite to the third one for the condition of equilibrium to be established. Thank you.